Hello guys, welcome back to Rev Games Academy. In today's tutorial, we're going to add some exciting enemy AI mechanics to your game, patrol and chase behaviors. These are essential features for creating dynamic enemies that not only patrol an area, but also chase the player when they get too close. This creates a more engaging and challenging gameplay experience. Let's dive right in. First, let's talk about what patrol and chase mechanics are. The patrol behavior allows enemies to follow a set route, moving smoothly between predefined waypoints. Even if the player isn't around, the enemies will still be active, giving the game a sense of life and movement. We can also make enemies patrol to random points within a defined area. Unlike predefined path setups, random pathfinding makes your enemies less predictable and more dynamic. This adds variety and a sense of unpredictability to your game. The core idea is to generate random positions within a specified patrol area and ensure these points are valid and accessible on the nav mesh. By doing this, we give our enemies the ability to patrol freely, making them appear more intelligent and alive. Chase behavior comes into play when the player enters the enemy's detection zone. When this happens, the enemy will start pursuing the player, which adds urgency and tension to the gameplay. The key here is managing these states efficiently so that enemies switch between patrolling and chasing based on the player's position. We'll use Unity's nav mesh system for pathfinding, which ensures smooth and natural movement across different terrains. With nav mesh, enemies will avoid obstacles, climb ramps, and find the most efficient path to their target. Here, you can see I've set up a simple scene with a player, an enemy, and a basic level. I've baked the nav mesh for enemy movement and attached a nav mesh agent to the enemy. For walls, I've attacked nav mesh modifier and marked them as unwalkable, so the enemy avoids them as part of the patrol. In the nav mesh settings, I've excluded the player layer to prevent the enemy from treating the player as an obstacle. Now, let's move into the code and walk through the random patrol and chase behavior script step by step. This script creates a dynamic enemy AI system with two key behaviors, patrolling and chasing. During patrol, the enemy moves to random points within a defined area, making it feel alive and unpredictable. When the player enters the detection radius, the enemy shifts to a chase state, pursuing the player in real time. This system enhances the game's immersion and provides an engaging challenge. We start by setting up patrol variables. The patrol area center defines the center of the patrol area, and patrol area radius sets how far the enemy can roam. The patrol point min distance ensures the enemy doesn't choose points too close to their current position. For the chasing section, the player variable references the player's position, and the detection radius determines when the enemy detects the player. The chase stop distance defines when the enemy stops chasing. The nav mesh section includes the nav mesh agent, which handles movement and pathfinding. Finally, is chasing and is patrolling track the enemy's state while current patrol target stores the enemy's current patrol point. In the start method, we initialize the nav mesh agent, which handles the enemy's movement along the nav mesh. We also generate the first random patrol point to give the enemy an initial target. This setup ensures that the patrol begins immediately as the game starts. The update method governs the enemy's behavior by checking its current state. If patrolling, the enemy moves toward its current target. If the player is detected within a specific radius, the enemy begins chasing. Once the player moves out of range, the enemy stops chasing and resumes patrolling. The patrol method is responsible for moving the enemy between random patrol points. If the enemy reaches its current destination, it generates a new random target. This continuous movement within a defined area creates dynamic and unpredictable patrol behavior. The generate random patrol point method selects a random point within the patrol area using Unity's random inside unit sphere. It ensures the point is valid and reachable by verifying it against the nav mesh. If a suitable point is found, the enemy moves toward it, keeping the patrol realistic and within boundaries. The start chasing and stop chasing methods manage the transition between patrolling and chasing. When the player is detected, the enemy switches to chasing mode, focusing entirely on the player. Once the player escapes the detection radius, the enemy resumes its patrol, ensuring smooth and logical behavior. In the chase player method, the enemy continuously updates its destination to follow the player's position. This makes the pursuit feel responsive and relentless. If the player gets too close, the chase temporarily stops to prevent overlapping or unrealistic interactions. Finally, we use distance checks in the player in detection range and player out of range methods to determine the player's proximity. If the player enters the detection radius, the chase begins. Conversely, if the player moves out of range, the chase stops. Now, let's see this in action in the Unity editor. With the player outside the enemy's detection range, the enemy patrols randomly within the defined area. Notice how it moves dynamically and unpredictably, adding life to the game world. Now, as the player approaches the enemy, it detects the player and begins to chase. The pursuit continues until the player escapes the detection radius. At this point, the enemy seamlessly resumes its patrol. By implementing patrol and chase mechanics, we have created a dynamic and engaging enemy AI system. With Unity's nav mesh, we ensured smooth movement and obstacle avoidance, making the AI feel more intelligent. You can customize the patrol area, detection range, and chase speed to suit your game design. That wraps up today's tutorial on implementing patrol and chase mechanics for enemies in Unity. I hope you found it helpful and that you're excited to implement these dynamic AI behaviors into your own game. By using NavMesh and random patrol points, you can create intelligent enemies that not only react to the player, but also keep the world feeling alive and engaging. If you enjoyed this tutorial, don't forget to like, share, and subscribe to the channel for more game development content. Also, feel free to leave a comment below if you have any questions or if there's a topic you'd like us to cover in future videos. Thanks for watching and keep coding. See you in the next one. Happy developing, guys.